Hi everyone, today we're going to find the point of intersection using algebra, and we're going to use a strategy called substitution to do this. So in order to understand how substitution works, we need to first recognize that both of our equations that we've been given are solved for y. They're in the form y equals mx plus b. So we're told that y equals 2x minus 3 and that y equals negative 2x plus 5. Because we know that both of these items are equal to y, we can match them together as in 2x minus 3 is equal to negative 2x plus 5, and we can use this to find the x-coordinate of where the lines intersect. So we'll solve this equation as we normally would, thinking about the houses and moving the x terms to one side of the equal sign and the number terms to the other side of the equal sign. Don't forget that when a term crosses over the equal sign, it has to change its sign from being positive to negative or vice versa. This will leave us with 2x plus 2x is equal to 4x, and on the right-hand side, we'll have 5 plus 3 is equal to 8. We'll need to divide both sides by 4 to get the x isolated, and this will leave us with x equals 2. This is the x-coordinate of the point of intersection. We can use this x-coordinate, or this x value, to find y. We get to choose which of the equations we want to use to find y. I'm going to pick the first one in this case, just simply because it has a positive coefficient in front of the x, so it seems like it'll be a bit easier to use. So I'll write out the equation y equals 2x minus 3, and I'll substitute my known value of x, or x is equal to 2, into the equation. This will leave me with 2 times 2 minus 3, and then I'll know that y is equal to 4 minus 3, or y is equal to 1. This is the y-coordinate of the point of intersection. So we can conclude that our point of intersection is 2, 1. In our second example, we'll use the same strategy of substitution by matching up the two sides of the equation. So if y equals negative x plus 1 and y equals negative 2x plus 5, that means that negative x plus 1 must equal negative 2x plus 5. We'll solve this equation by moving the negative 2x across the equal sign and turning it positive, and moving the positive 1 across the equal sign and turning it negative. Negative x plus 2x will give us just x, and 5 minus 1 will give us 4. So our x-coordinate for the point of intersection will be 4. Now, we need to find y. We'll use equation 2 in this case. So I'll write out the equation y equals negative 2x plus 5, and I'll substitute in our known value of x equals 4. When we do that, we'll have y equals negative 2 times 4 plus 5. That will mean y is equal to negative 8 plus 5, or y is equal to negative 3. And now we have the y-coordinate of our point of intersection. So we can put these two things together and say that the point of intersection is 4, negative 3. Just a note, I chose to use equation 2 here to find my y value, but I could just as easily have used the first equation and I would have got the same answer of y is equal to negative 3 as the y-coordinate. In this example, our equations are in the form c equals, but we'll notice that they're both in the same format. So we can still match up equation 1 and equation 2. If c equals 10x and c equals 5x plus 100, then that means that 10x equals 5x plus 100. We can move the 5x across the equal sign to be with the other x's. That will turn it into a negative 5x. And then we'll subtract. 10x take away 5x will give us 5x, and that will equal 100. At this point, we'll need to divide both sides by 5 to get the x by itself, and that will leave us with x is equal to 20. So our x-coordinate of the point of intersection is going to be 20. We're going to need to find c. This is the other variable that we don't have yet for our point of intersection. It's our dependent variable. Let's use equation 1 this time because c equals 10x is simpler than the alternative c equals 5x plus 100. So I'll write out the equation that I'm going to use, c equals 10x, and I'll substitute my known x value of x equals 20. This will leave me with c equals 10 times 20, or c equals 200. So now we have our dependent part, or coordinate of our point of intersection. So we can put them together and conclude that the point of intersection will be 20, 200. This is how we find the point of intersection using substitution.